Hey, hi all. This is Priyanka Singh. How are you people? And today we will be discussing this coding problem in stack, which we have already discussed in my previous videos. But today I've again come up with a problem because many of you have asked me to solve it using a single stack and a constant memory. Alright, so this is a bit optimized solution in comparison to my previous video. I strongly suggest you guys to go through that solution first in order to get approach how to solve this solution, and then you can move on to an optimized one. Okay, so I'll provide the link up here. All right, you can watch that video and then come back here to get an optimized solution of it. And before looking into the optimized solution, I strongly recommend you guys to try it once on your own. So I'll reiterate my question for you here. Here, design a stack that supports push, pop, top, and retrieving the minimum element in constant time, where push X says to push element X onto stack. Push removes the element on the top of the stack. Top, it gets the top element off from the stack, and this get minimum function, it retrieves the minimum element in the stack. All right, so if we talk about this problem here, first of all we'll be instantiating the class, whichever class we are having, and then we will push minus 2, then 0, then push minus 3, get minimum. What does it do? It finds the minimum out of these, which is minus 3, hence we will return with minus 3 for this particular function. Okay, and for this pop, we will pop the last element that we just inserted, which is minus 3. Then we will get the top. After removing minus 3, we are left with minus 2 and 0, where 0 is at the topmost position. Here we hence we will return 0. Then for this get minimum, out of these two, minimum is minus 2, hence we will return with minus 2. Alright. So here constraint method, pop, top, and get minimum operations will always be called a non-empty stack. Alright, so let's solve it in an optimized way. Earlier I took two stacks. Here I'll be taking just a single stack. Okay, and this is a wrapper. And a constant memory space called min, where I'll be storing integer max value, where I will be storing the minimum value as far as we have. All right, so this is to make this function in constant time. Okay, so that we can return minimum in a minute away, right? Otherwise we have to otherwise we have to parse all the stack and then see what is the minimum. Then it makes no sense, because then it will take a time complexity of big O of n. But to reduce that, I'm having a variable minimum handy, so that whenever user asks me to get minimum, I can just return it at the moment. Alright, and here I will instantiate these values. I'll instantiate these variables. And instead of doing this here, it's preferable to instantiate the variables here in the constructor instead of doing that here. Alright, so while pushing, what I'll be doing, um, first of all, I have to push the element in the stack, right? But how to but what if I delete something from the stack? Okay, and that is the minimum element, then I will lose the second minimum element. Hence I will be pushing the minimum elements along with pushing this along with pushing this element. Okay, so what I can do is, and also one more thing, we need to keep in mind that when we are asked to return top, we will be returning this stack dot peak, right? So hence, whatever element we are pushing currently, that should be on top of the minimum value. Okay, so here I will check if my minimum is lesser than or equal to the x. Okay, in that case, I will push the minimum, whatever minimum I had till now, that I will push into the stack in order to preserve it if that minimum elements gets popped. Okay, so that is how I'm preserving second minimum, third minimum in my in the same stack itself. Okay, so that is what I did, and then I need to update minimum value of minimum as well. So just I'll have a look upon it. What I did, whatever x I'm going to push, if it is less than minimum, then we need to push the minimum, and then we need to, okay, update the minimum and then push the whatever element they have asked us to push. All right, and while popping, I have to check if this is equal to minimum or not. If this is equal to minimum, then I need to delete one more element, because whenever it was equal to or less than minimum, then I had pushed two elements in the stack. Hence, if that is equal to minimum, then in the case of popping the element, at that time also I need to pop two elements. Remember this thing. If minimum is equal to stack dot pop, so we are going to pop something out of the stack, that is for sure. Hence, I've directly used this stack dot pop instead of saving it somewhere in the variable. Okay. Now, if it is equal to minimum, then I need to save the second minimum element. Okay. So that is how it is going to be. As I was not able to hit these buttons in that tool, so hence I have to switch to some another tool. So here what we have done, we have wrote the code till this point of time. Okay, now let's run it. Okay, all right, so this is giving us some error as we're inserting something wrong. So here this is an element that we want to insert, and we have to check if this new element is less than the minimum. Okay, so if this is less, then whatever was the previous minimum, we have to save it in a stack and then update the minimum value. Okay, let's try this out now. Okay, this seems well to me. Let's see for all the use cases. All right, so it got submitted. So this is how you can do it. So whenever you're solving a problem, first of all, your target is to solve the problem. Okay, once you're able to solve the problem, you can optimize it gradually after learning more tricks and more practicing more and more. Okay, so this was it, and hope you guys liked it. And if you have more suggestions in your mind, please let me know. I'll love to solve that here. All right, then happy coding, and do like, share, and subscribe my channel for more upcoming videos. Thank you.